We'll start by remembering what the Pythagorean theorem is about. So in prior years, we should have learned about first of all a triangle that is called a right triangle. It's a triangle with a right angle, such as the one you see here. Triangle ABC has a right angle, meaning 90-degree angle at C. So that is a right triangle. The two sides making the right angle are called legs, and the other side, which is the longest, is called the hypotenuse. And this theorem says that when you add the squares of the sides making the right angle, then you always get the length, the square of the length of the third side, right? So the plus goes for the two lengths, the squares of the two lengths forming the right angle. That's how you can remember better than remembering A, B, and C. And so every time you have a right triangle, you have this relationship between the lengths of the sides. But the converse is always true. So we'll see here that if you have any three numbers that are in that relationship, if you imagine three numbers for which the sum of the square of two of them equals the square of the third side, then you can always count on those three lengths will form a right triangle, meaning being C, the length of the hypotenuse, and A and B, the length of the legs or the sides making the right angle. So that is something that you should have learned in prior years, but then let's have a look at example 1. So in example 1, we want to prove that that is actually true. So how can we be absolutely sure that the sum of the squares of the two lengths of the sides making up the right angle equals the square of the length of the hypotenuse? Let's listen.
Triangle XYZ is a right triangle. Prove a squared plus b squared equals c squared. Note the vertical side xy has a length of a. The horizontal side xz has a length of b. And the hypotenuse yz has a length of c. Plan. To prove the Pythagorean theorem, draw the altitude to the hypotenuse. Then use the relationships in the resulting similar right triangles.
So the altitude is the perpendicular segment that goes from x and intersects yz, making a right angle. So that is a segment that is perpendicular.
First, draw altitude xw. Altitude xw with a length of d is perpendicular to the hypotenuse, forming a right angle at its intersection with the hypotenuse. Due to the inclusion of the altitude in point W, the hypotenuse can now be considered as two segments. Segment YW with a length of E and segment WZ with a length of F form the hypotenuse YZ with a length of C.
That in other words means that E plus F equals C.
Adding an altitude to the original right triangle XYZ has created two right triangles within triangle XYZ. All three of these triangles are similar to each other. Thus, triangle XYZ is similar to triangle WXZ, which is similar to triangle WYX.
So now by writing the corresponding proportions, having those similarity statements, it'll be easier to reach the conclusion that we want.
Because triangle XYZ is similar to triangle WYX, C over A equals A over E.
Notice that C is the hypotenuse of the big triangle, and that corresponds to A, which is the hypotenuse of one of the little triangles over here. When you are dividing by A, that means that you're dividing by one of the sides of the big triangle. And of course, if we are comparing that to the little one, that is the same as dividing A by E. So those two are the sides we're talking about. So that's why you see E right there. So as a conclusion, when you do cross multiplication, C times E equals A times A, that we can write as A squared.
So A squared equals C times E. Similarly, because triangle XYZ is similar to triangle WXZ, C over B equals B over F. So B squared equals C times F. Finally, to prove the Pythagorean theorem, we need to write an equation that relates A squared and B squared to C times E and C times F. Because we know A squared equals C times E and B squared equals C times F, we can generate an equation by adding these two equations together. Now, start simplifying the equation by factoring. Then recall that E plus F is equal to C. So A squared plus B squared equals C squared. Therefore, the Pythagorean theorem has been proven.
There are many other proofs of this result, and I invite you to search the web for those. So let's see. In this case, if they ask us to find the length of AB, we can use the Pythagorean theorem, raise this leg to the second power plus the length of the other leg to the second power. That'll give us the square of this length. So at the end, if we just take the square root of the answer, it'll give us the result that we are looking for. So give it a try and check your answer here, please. The answer could be a radical that is simplified. So if you got 9 in the square root, 9 times 41, which is 363, sorry. Oh no, that I was right the first time, 369. Then that is the same answer as this one, so you got it right. So, my goodness. Okay, so let's see if we can see example 2 right here. So in example 2, it says that to satisfy safety regulations, the distance from the wall to the base, so that is the number that you see at the bottom, should be at least 1/4 of the length of the ladder. 1/4. So if it is less than 1/4, then that is a dangerous position for the ladder. Did you set up the ladder correctly? Let's see if that is, first of all, we're gonna find the length of the ladder, and in finding that, we're gonna use the Pythagorean theorem. So remember, these two sides form the right angle, so if you square this side plus the square of the other side, I should get the square of the hypotenuse, which is in this case the length of the ladder, the square of the length of the ladder. So knowing that the square of the length of the ladder is 87.25, if we take the square root on both sides, we get that C equals 9.34. So I just gotta check that this number here is at least 1/4 of 934. But So because 1/4 of 934 is 2.335, so 335 thousandths, that means that we are actually have at least that number, so we're being safe. For this example, we're using the converse of the Pythagorean theorem. So a, a rancher is building up this fence so that this is 6, 8, and this is 10 feet according to the information. They're asking us, why does this make sense? Well, if we think about it, those three numbers, 6, 8, and 10, form what is called a Pythagorean triple, and that is basically three positive integers in the relation a squared plus b squared equals c squared. So if we raise 6 to the second power plus 8 to the second power, we get 10 to the second power. So that is a Pythagorean triple, and that is making sure that this vertical post there is actually vertical to the ground. So it makes a 90-degree angle, and that makes it stable. So with those two ideas, let's see if we can answer, first of all, this one. As always, stop the video and check the answer after you tried something, and then check the other one. They're asking us if that is a right triangle. Remember, the sum of the squares of the two lesser numbers should be the square of the other number if that is a right triangle. So please give it a try. The calculator basically will tell you the answer. And in this case, yes, it is, because 35 to the second power plus 12 to the second power, in fact, is the same as 37 to the second power. So it is about a right triangle. So I will record another video for the rest of examples.